Now, there's other ways we can talk about position, and that would be with percentiles and other fractiles. So there are other measures of position as well. We have seen quartiles already, which divide the data into 4 equal parts using Q1, Q2, Q3. There are also deciles, which use the notation D1, D2, and so on, which divide the data into 10 equal parts. And then finally, there are percentiles, which we're going to focus on here, which divide the data into 100 equal parts, right? Because a percent is out of 100. So we use P1, P2, P3, and so on to represent those percentiles. Now, the first quartile is actually the same thing as the 25th percentile. The second quartile, or the median, is the same thing as the 50th percentile. And your third quartile is the same thing as the 75th percentile. Now, what that notation looks like is your first quartile equals the 25th percentile. Your second quartile equals the 50th percentile. And then your third quartile equals the 75th percentile. So for the percentiles, we write the little number there next to it for which percentile we're referring to. Now, the interpretation of them is really important. When we interpret percentiles, we are considering how much of the data set lies below them. So for instance, if someone scores on a test in the 95th percentile, that means that they scored the same or higher than about 95% of the class. So about 95% scored below them and about 5% scored above them. Now, it's 5% because we always need 100% altogether. So 95 plus 5 is the 100. So that percentile gives you the cutoff for how much scored below. So if I say the 25th percentile, that means 25% below the cutoff, 75% above the cutoff. If I say 50%, that's right in the middle, 50-50 on each side, okay? So when we're talking about 95% cutoff, for instance, P95, then this means you have 95% of your data here, and then only 5% of your data higher than it, okay? So that's how we interpret it. So here we have an ogive graph on the right, and it represents the cumulative frequency distribution for SAT scores of college-bound students in a recent year. What score represents the 80th percentile? So how do we read this graph? First of all, we see our percentiles here on the y-axis, and then we see our SAT scores here. So by lining this up, the 80th percentile is over here, and then if I take that point and I go down, it looks like it's right in between 1200 and 1300. So that score is about 1250. So what does this mean? It means that approximately 80% of the students had an SAT score of 1250 or less, right? So here's our 80th percentile. So that means 80% scored below and 20% scored above, and that SAT score here was at 1250. So around 80% of the students had below a 1250, and around 20% had above a 1250. Okay, now that 1250 can kind of go in either category. It's not a clear cutoff of you have to be strictly less than or greater than. So that's why they say here 1250 or less is usually the interpretation. We can also find percentiles that correspond to a specific data entry, and we can use the following formula. So the percentile of x meaning a data point, is the number of data points less than that data point divided by the total number of data points times 100, and then round to the nearest whole number. Now, this sounds a lot trickier than it is. It's really not that complicated. So first thing, whenever you're talking about percentiles, quartiles, and you're doing it by hand, you do need to make sure your data is in order, if it's not, right? Because this is about a position in the data, so it has to be in order from least to greatest. Okay. So I do have a data set here that's already been ordered, again, to save us some time. So consider the data set for tuition costs for 25 liberal arts colleges. These values are in thousands of dollars. And we're going to find the percentile that corresponds to specifically the data point 34,000. Now I have two data points that are 34,000, but I'm going to use the first one. So look at our formula, the number of data entries less than X. So strictly less than. So here's 34. The numbers that are less than are right here. I have 1, 2, 3, 4, 5, 6, 7, 8 data points less than that. I have 25 data points altogether. So the percentile here of $34,000 is 8 divided by 25. It's the number of entries less divided by the total number of entries, which is 25 here. And then we're going to multiply that by 100, of course, to get the percent. I can even put a little percent sign if you want, but you don't have to. All right, so if I go ahead and multiply this out, I have exactly 32. All right, let's show you this for a second. So when I do 8 divided by 25, I get 0.32, multiply by 100, and I get 32. So what this refers to is the 32nd percentile. So again, I like to just draw little pictures here. I just think it helps so much. So this is the 32nd percentile. So 50% is about the middle. So maybe it's like right here, right? Percentile for 32. So you have about 32% below. And then let's see, I'm going to have about 68% above to get the 100. And this value is $34,000. So only about 32% of the schools had costs that were lower than $34,000. Now, again, this is one way to find a percentile. Just like with quartiles, there actually are numerous ways that you can calculate them, depending on if you want to include or exclude end values. So here we're not including the end value of 34. If we did, we get a very different answer. So again, on technology and things like that, if you happen to, you can do these in Excel as well. I'm not going to go through that because I think they're pretty fast to calculate by hand. But if you were using technology, do know that there are various ways that you can do it, just like with quartiles. So if you get slightly different results, it's not that it's necessarily wrong. It's just that you can either exclude the end points, so like I'm not including 34, or you could include them and you get different results there. So we'll go with this version, which is what your text recommends.